Welcome to This Explainer. Today, we're unpacking the staggering ambition and really the ultimate heartbreak behind the world's largest passenger airliner, the Airbus A380. It's this absolutely fascinating story of engineering triumphs, literal logistical miracles, and a pretty harsh collision with economic reality. At its heart, we're really looking at a massive mystery. How does a $25 billion engineering marvel end up becoming a commercial failure? We're going to dive right into the story of an aviation giant that was basically born to conquer the skies, only to have the ground completely pulled out from under it. So our story actually kicks off way back in 1988, and it begins in total secrecy. A team of Airbus engineers quietly started working on a project they dubbed the Ultra High Capacity Airliner, or UHCA. They had one singular target in mind: build a massive double-deck aircraft to completely shatter the monopoly Boeing had held for decades with its iconic 747. Boeing totally owned the skies in that large aircraft category, and Airbus, well, they wanted the crown. And man, the sheer scale of their ambition here was just off the charts. Airbus was aiming to undercut their rival drastically. They targeted a 15% lower operating cost than the Boeing 747-400. To pull that off, they designed a true Leviathan. We are talking typical seating for over 500 passengers, with the structural ability to pack in a maximum certified capacity of 853 people. Combine that massive payload with an unbelievable range of 8,000 nautical miles, and you've got an aircraft that can connect almost any two major cities on the planet. By December 2000, feeling super confident in their vision, Airbus officially launched this multi-billion-dollar bet on the future of air travel. But as you can imagine, bringing a machine of this size into reality wasn't just a design challenge. It was a massive geographical puzzle. Constructing this mega project, which had a maximum takeoff weight of over 600 tons, required an unprecedented continent-spanning logistical effort. The parts were just way too huge to be built in any single factory. To actually make this happen, Airbus orchestrated this incredibly complex route known as the itinéraire à grand gabarit. Get a load of this process. They built the massive fuselage sections in Germany, then shipped them to France. The enormous wings, manufactured in Wales and floated on specially designed barges down to Mostyn docks. From there, they loaded these gargantuan parts onto custom roll-on/roll-off ships, sailed them down to Bordeaux, and finally transported them on oversized road convoys. These convoys literally had to crawl through tiny French villages in the dead of night just to reach the final assembly hall in Toulouse. It was this perfectly choreographed dance of ships, barges, and trucks spanning all of Europe. But eventually, the sheer, staggering physical scale of the A380 caught up with it. Consider this number for a second: 530. That is 530 kilometers of electrical wiring required inside each and every aircraft. Having to thread 98,000 individual wires and 40,000 connectors through the incredibly tight spaces of every single cabin, that quickly turned into a severe, crippling bottleneck for Airbus. So why was this wiring such an absolute nightmare? Well, you're probably not going to believe it, but the culprit was incredibly basic: incompatible software. The Airbus facilities over in Germany and Spain were using CATIA version 4 for their computer-aided design, while the teams in Britain and France had already updated to version 5. When all these physical parts finally met on the assembly line, the designs literally did not match up. The wiring harnesses were too short, or they bent the wrong way. This one digital disconnect caused massive configuration failures and ended up delaying the entire production run by 2 full years. Despite these brutal delays, which, by the way, caused development costs to nearly double, the so-called Superjumbo did finally take to the skies. The A380 officially entered commercial service in October 2007 with Singapore Airlines. And honestly, despite all the behind-the-scenes chaos, it totally astonished the world with its massive size, how quiet it was, and its unparalleled comfort. If you were lucky enough to actually fly on one in those early days, you know exactly what I mean. For the passenger, the A380 delivered spectacularly on its promises. It burned 20% less fuel per seat mile than its Boeing rival, so it was highly efficient for its size. Thanks to some really advanced engines and sleek aerodynamics, it produced half the ambient noise. Plus, that massive double-deck structure gave passengers this remarkably quiet, vast, almost palace-like experience in the sky. It really felt like the golden age of flying had made a comeback. But here's the catch. While Airbus was busy perfecting their giant, the Earth was shifting right beneath them. The fundamental economics of the global airline industry were quietly, slowly changing. A completely new reality was taking shape out there, while the A380 was still sitting on the drawing board. See, the A380 was fundamentally built for a hub-and-spoke world. That's a system where traffic gets consolidated into a few massive mega hubs. Think London Heathrow or Dubai, before distributing passengers out to smaller cities. It's a kind of travel where you almost always have a layover. But the industry was rapidly shifting toward a point-to-point model. Airlines realized they could use a new generation of smaller, highly efficient wide-body twin jets to fly passengers directly from their origin straight to their final destination, completely bypassing those congested, stressful mega hubs. Passengers definitely preferred direct flights, and airlines loved the flexibility. Because they didn't need massive capacity concentrated at those single mega hubs anymore, airlines faced a really stark economic reality tied to the economy of scale. To get any cost advantage from a massive plane, you absolutely have to operate at massive volumes. But many airlines simply couldn't get the consistent passenger numbers required on enough routes to justify the immense fixed costs and the specialized airport infrastructure needed to support such a huge aircraft. An A380 really only makes financial sense if you can fill all 500-plus seats day after day, flight after flight. If you have empty seats on a plane that big, it's just pure financial loss. To make matters worse, adding to this intense financial pressure was a fatal structural flaw hiding right in plain sight. Unlike the Boeing 747, which has survived for decades, largely because it makes a phenomenal cargo plane, the A380's passenger-optimized design made a viable cargo version literally impossible. Because they put the cockpit below the main deck, and because the upper floors were built as an integral part of the plane's structural integrity, you couldn't just hollow it out or slap a hinged nose on the front for oversized freight. This structural reality effectively killed any fallback cargo orders that might have kept the production lines moving once passenger orders dried up. So the math quickly turned totally merciless. The estimated development cost had skyrocketed to $25 billion. The price tag for just one aircraft sat at an eye-watering $445 million. But to actually break even on the whole program, Airbus needed about $90 million in pure profit for every single plane they sold. With orders drying up in this new point-to-point market, they couldn't even cover the production cost of a single plane. That made it virtually impossible to ever recoup that initial $25 billion investment. The financial hole was just way too deep. Those final years of the program turned into a really tense countdown. In 2018, Emirates, which was the A380's biggest champion and pretty much the one airline that truly made the hub-and-spoke model work, secured the production line briefly with a lifeline order for 36 more jets. But then, in February 2019, the final blow landed. Emirates dropped those orders in favor of smaller, more flexible twin jets. That exact same month, bowing to the inevitable, Airbus was forced to announce the end of A380 production. The final aircraft was meticulously assembled and delivered in December 2021. The brutal reality of the situation was summed up perfectly by Airbus CEO Tom Enders, who starkly admitted, if you have a product that nobody wants anymore or you can sell only below production cost, you have to stop it. It was a really bitter pill to swallow for everyone involved. Despite it being an absolute marvel of engineering and a plane genuinely loved by almost everyone who flew on it, the market's needs had simply moved on. So, what was the final tally? Just 254. They only ever built 254 of these incredible machines before the massive assembly lines in Toulouse were shut down for good. That is a far, far cry from the thousands of Superjumbos they originally hoped to sell when the program was cooked up in secrecy all those decades prior. Which leaves us with a really fascinating question to ponder. The next time you board a direct flight, which is, let's face it, probably going to be on one of those highly efficient twin jets, think about this. Was the A380 a massive engineering miscalculation, or was it just a beautiful dream that arrived an era too late? Thanks for joining me for this explainer. I hope it gave you a much clearer look into the incredible ambition and the harsh economic realities behind the Superjumbo.